morning everyone. I am Tanushree Dorai from Civil Engineering branch. So in the last class, we just initiated this question up to the finding out the section. So by two factor, we found out the section which is a channel type section, and the two factors are, first one is your factored axial load, which is 400 kilonewton, which is given in the question, and second factor is the permissible design compressive stress, which we took as 80 MPa, by which we got the value of area required, which is 5000 mm square. So as per the area required, that area provided which we will provide for this particular channel section, that may be always greater than the 5000. So from the steel table, we got the area provided value in the channel section as 5366 mm square, and this area is for the ISMC 350/413 Newton per meter section. So after finding out the section type, we need to write the properties of this section, which is ISMC 350. So the RZZ equal to 136.6, RYY equal to 280.3, and here in this channel section we will take the minimum of the radius of gyration in ZZ axis and YY axis, which is 28.3 mm, and the condition is given as effectively held in position at both ends but restrained against rotation at one end only. So according to this condition, the relationship between actual length and effective length is 0.8 L, which is the value of effective length. So L is given, which is 4 meter, and we have to convert this one into mm, that is 4000 mm. So this question we will solve in method 2. So the value of slenderness ratio is equal to effective length by radius of gyration. So the effective length is equal to 0.8 into 4000, which is 3200, divided by radius of gyration, which we took as the minimum of radius of gyration in ZZ axis and YY axis, which is 28.3. So the value is 113.07. So according to this slenderness ratio, we will find out the FCD value from the table number 9. As we know that in method 2, we can directly find out the FCD value from the table number 9. So as we know that this is a channel section, so for the channel section there is no condition, so we can directly put the value of buckling class as C, which we can find out from the table, that is in the table number 10 in IS code 800/2007. So here you can see for the channel section the value of buckling is class C. So to find out the FCD value, we can find out the slenderness ratio, that is 113.07, and for the 113.07, what is the value of FCD as per the FY value? Because in the table number 9, in that part only two factor is needed to calculate the FCD value. First one is your slenderness ratio and second one is your yield strength of the steel. So we know that for Fe410 the Fy value is 250. So we can got the value of FCD as 91.25 Newton per mm square by interpolation method, because in the table number 9 the slenderness ratio is given as the round figure like 10, 20, 100, 110, 120. So you can find the value of slenderness ratio for the 110 and 120. So there are two types of FCD value you may get, and after that by the help of interpolation method you can find out the FCD value for the 113.07 slenderness ratio, because the 113.07 slenderness ratio lies between two numbers, which is 110 and 120. So by applying the interpolation method, we got the value of FCD as 91.25 Newton per mm square. Hence, the last part of the solution, which is design strength or the factor axial load, that is PD equal to AE into FCD. So we got the FCD value as 91.25 and AE value is 5366, which is the value of ISMC 350. So by multiplying these two factors, we got the value of PD as 489.65 kilonewton. So the PD value should be greater than the value of factored axial load, which is already given in the question. So this condition should be satisfied for this question. If it is not satisfied, then we have to redesign this section. That means we have to find out another area provided which is greater than this one. Then we will continue this procedure again. So in this way, we can calculate the compression member and find out the compressive stress as well as the compressive strength of the section. Now, another problem is there, which is based on a double angle section. So the question is, a discontinuous strut consists of two unequal angles. The section is 125, 75, 8 mm thick with long legs connected to the opposite side of the gusset plate of 10 mm thickness by two bolts on each angle at both ends. The length of the strut is 3.3 meter. Hence, determine the ultimate load that the strut can carry if the Fy value is 250 MPa. So here the section is an angle section which is unequal in nature. You can identify the angle section whether it is equal or unequal by these first two values. This is the value of the leg of the angle section. So here the angle section is 125 into 75. That means one angle, that is one leg of the angle section is 125 and the other leg length is 75 and 8 mm is the thickness of the angle section. And here the question says that there are two unequal angles which is connected to the opposite side of the gusset. That means your figure is look like this. So here is your gusset plate which thickness is 12 mm and the longer leg of the angle section is connected to the opposite side of the gusset. So you can see this one is your longer section of the angle and this one is your shorter section of the angle, that is shorter leg. So the longer leg of the two angle section is connected by bolting to a gusset plate. So first of all, we need to find out the properties of the angle section 127/75 into 8 mm. So the area of the angle section is 3076 mm square. The radius of gyration along ZZ axis is 40 mm. The radius of gyration along YY axis is 30.2 mm. And here also we will take the minimum of the radius of gyration, which is 30.2. And for the angle section, the effective length of the section will be 0.85 times of the actual length, which is already given in the IS code 800/2007 in clause number 7.5.2.1. Hence, we can calculate the effective length of the angle section as 0.85 L. That is 0.85 into L value is 3.3 meter, which is 3300 mm. So by multiplying this, we got the value of effective length as 2805 mm. Hence, the area of the section is given as 3076, which is given in the steel table. Then, as we know that it is an angle section, so that directly we can take the buckling class of C from the table number 10. So the slenderness ratio is 92.88 and the buckling class is C. So we can find out the FCD value from the table number 9C. So in the table number 9C, the slenderness ratio, that is 92.88, lies between 90 and 100. So first of all, for the 90, one FCD value is there. For the 250, yield strength, and for 100, another FCD value is there. So by help of the interpolation method, we can find out the FCD value as 116.968 Newton per mm square. Hence we put the value of PD, which is equal to AE into FCD. So AE value is 3076 and FCD value is 116.968. So by multiplying these two, the value of PD equal to 395.793 kilonewton. So this is the value of angle section. So today this much. Thank you.